Now we're going to solve for the trajectory of a rocket. A rocket is thrust upward into the air with an initial velocity of 15.0 meters per second. Calculate how high it goes, how much time it takes for it to reach the height, velocity of when it returns to the ground, and what time the rocket passes a point 8 meters above the launch pad. So first we need to draw the trajectory as a body diagram. A is where the rocket starts, B is where the maximum height is, and the rocket returns to the ground at C. We need to find time, so we're going to find distance, which is the x sub f, and we're given velocity, which is 15.0 meters per second, and the velocity final is 0 because when the rocket reaches the apex, it's no longer moving upwards. It will be 0 for just a moment and then return back to the ground. Acceleration is the same thing as gravity when it involves objects moving up and then back down. And the acceleration is negative 9.8 meters per second squared. The equation we're going to use is v sub f equals square root of v sub I squared plus 2a delta x. Now if we're solving for delta x, which is the x sub f, we're going to square both sides to cancel out the square root. Then we need to isolate the x by subtracting vi squared from both sides. And then we need to divide both sides by 2a to get delta x by itself. And this is our final answer for the formula to use. Now students always ask, what is triangle x? That's x final minus x initial. X initial is 0, so we don't need to include it in the calculation. It would be x sub f minus 0 as our final answer, which is the same thing as x sub f. So let's go ahead and plug in. We have 0 for v sub f. We have 15 for v sub I, and negative 9.8 for a. Simplify, simplify, and there's your final answer.